Well,
Mr. Gugasian, it's Sean.
alright, you got the money?
I did indeed.
Alright, good. Good. Now, the thing is, if you get a room, where are you going to work on that thing? In the room? Or maybe you can get a room next close to a garage or something, I think.
I
What do you
could.
think?
I literally have not looked into it yet this morning. I mean,
Right,
like I said, I've been doing all that running around. When you said
right, right.
not to get started on it until I called you, that's actually a good thing. Because like when you first asked me about it, I was literally trying to give it to Mr. Maddox so that he could use it, make money with it, or give it away for free, whatever he chose to do with it. But the thing is, when you asked about it, I designed it as specifically as a jet engine for a high speed model jet, you know?
Right,
So,
right. Model airplane. Right, that's what I want. Yeah,
right.
yeah.
But when you said, like to use it as a weapon,
Right,
the thing is, like the way that I designed it, like
right.
we're talking about something that's ultra lightweight and ultra high speed. Now it'll carry a payload. I mean, it'll move something that's heavy like that, you know, because like when you're talking about the difference between uh, like 2 pounds worth of weight difference is a lot of weight difference when you're talking about uh, something like this pushing it. So, like, say it's an anti-tank charge, right? Like it's a
Right.
shape charge. So if it's a shape charge and you're going after a modern tank, a lot of the modern tanks actually have explosives on the outside of them that'll
Right, they blow
basically,
up. Right.
right, they blow up
They blow
whatever
up
it is
from
that
the
hits them.
outside. Yeah.
So you need something that's traveling supersonic with that weight in order to accomplish that. But the other thing is, since it's being designed, for a weapon, it needs to be specific designed. Like, say for example, all right, Frank
Hello?
Whittle. Yeah, I'm here.
Oh, yeah. What I'm thinking is a. Now you said you can. The type you have is 50 pounds of thrust.
Yes, sir.
And so that could carry what, about 30 pounds of weight?
Well, the one that I made was actually like 48 pounds of thrust. It wasn't quite 50, but it
Right.
not 30 pounds, three pounds.
Oh, you mean it can't? It doesn't carry a lot of payload. It's not able to.
No, it definitely could. As long as you used it and took it off from a sloped ramp, or if you had a way to travel it along the ground or whatever, you could probably lift, I don't know, with 50 pounds of thrust. I wouldn't
Oh.
think I wouldn't think you'd
So,
be able to.
so just that 50 pounds of thrust. If you had the wings on it, just like a model airplane, let's say the wings are, I don't know, a foot wide and 3 or 4 foot long or something like that, wingspan, 6 foot wingspan.
Like a
How much
small
weight
drone.
would you put?
All right. Well, as long as you make the wings so they're at least a 45-degree angle, because if you're talking about something that's going to go supersonic, then it has to have at least a 45-degree angle of break. Otherwise, the basically when it breaks the sound barrier, it'll tear off anything that's outside of that 45-degree cone.
Oh, it'll tear the wings off.
Yeah.
Mm-hmm.
But the other thing is,
Yeah, go ahead.
I got like, all right, I got like three really important questions as far as the manufacturing process goes. Because if I'm going to make it, I don't make things with the intention of making 10,000 of them. I make them with the intention of giving it to somebody, along with
Okay.
the materials and knowledge to make more of them themselves if they want to. So basically,
Right,
if
right. That's
somebody wants
exactly
it,
what I want to do. Yeah.
right. So what I'd be sending is um, the forums, anything of that nature, so that there could be multiples made. But the other thing
Uh-huh.
is, if I'm going to do that, and we make something that's specifically just for a small jet for exhibition at an RC show, that's one type of construction, and that would be made out of high quality materials like stainless steel and stuff like that. Also, if it's something that, like, say, an RPG-7, right? It's a throwaway weapon. You fire it, it hits the thing, it blows up. It's not necessarily going to sit forever and a day, but if it is going to sit for forever and a day, you can prevent oxidation just by painting the damn thing, which they do. But if it's going to be something that's throwaway, there's no need. Like, I got stainless steel to make it out of. If this is going to be something that's just going to be thrown away and something that's not going to be stored in a warehouse for, like, potentially 50 years, there's no reason that it can't be made out of less expensive materials. Like the fencing, for example, the tubing.
What less expensive materials are you talking about?
All right, the metal fence posts? Yeah, you could literally make 6 of these with 2 metal fence posts and have enough left over to make, quite a bit of stuff. I mean, they're not big engines. It's a very high power to weight ratio. I mean, we're talking about over 10 pounds of thrust per pound of machine. I mean, we're talking closer to 15 pounds of thrust per pound of engine. So I mean, we're talking about exactly. But the other thing is, like, whether it's made out of stainless steel or made out of something that's zinc coated, that's not going to matter. If it's something that's being thrown away, then zinc coated should be fine. And that's what most of the fencing is, and it's anywhere from $9 for a 8-foot stick to $22 for an 8-foot stick, depending on the diameter, which is a lot cheaper than the stainless steel, because I got a 42-inch piece of a smaller diameter for $32, and I think the other one was $38. So a lot of it is like, for the manufacturing process of it, is this something that's going to be used in a first world country or a third world country? I mean, produced in a first world or third world country.
I guess you could describe it as a second world.
Second world?
First world.
Almost first world? All right, well.
Probably a second, close, at least a second world, yeah.
So
there's a lot of stuff there. I mean,
So you're looking. The reason that I ask is because I can make this thing in the back of my vehicle right now in probably 25 minutes, because I'd have to use the hacksaw and my back screwed up. But I could literally make one in not very much time at all that will do something, like if people were making them in a third world country in a garage or a barn or something like that, then, that basically, I would send them a version of it that they could make with hand tools that they probably already have. So you wouldn't even need to send anything except the blueprints. And you might be able to get away with just sending them one. There are people in third world countries that are intelligent too. An engineer would look at it and go, "Oh my God, I get it." But the thing is, if it's in a first world country, I mean, then we're talking about different possibilities of manufacturing processes. So I'll tell you
what, consider it a first world country.
Consider it.
Right now they're building their own drones.
All right. Well, I've seen China caught one of our drones, and they made a copy of it, and Russia has a copy of it too.
I know.
At 50 pounds of thrust, this thing is not going to take one of those off the ground. I mean, it might, but you'd probably need 4 or 5 of them to get it up to any decent amount of speed. But the other thing is also, with something like this, it's a better idea to actually cluster a few of them together for something larger rather than make a larger engine.
Oh, I see. It's better that way. Why is that?
Well, partially because of fuel consumption, and partially because of the way that the sound baffle waffles out on something smaller. Basically, what you're using is the pulse jet portion is just most of your thrust is coming from steam at low speeds, and then as more air pressure is forced into it because it's traveling faster, then the
Right?
pulse jet starts to pick up more pounds of thrust, and
Oh,
the steam portion becomes less important. So basically, the steam portion is to keep it from overheating so that it'll last longer and to produce
sure.
the thrust to get it off the ground. Like when the Germans made the V1 rocket, they actually
Right?
fired it with Z-Stoff and T-Stoff on a ramp, basically a big backward ski slope, and they had to
Oh,
point the
yeah, yeah,
ski
I saw
slope.
those. Yeah, sure.
Well, they put
But
a
yeah,
piece of
yeah,
metal
but
in
I'm
there.
thinking since it's going to be radio, I'm thinking radio control, it would have wheels, like bicycle type wheels, tricycle on it. Two in the front, one in the front and two in the center. You understand what I'm saying?
Yes, sir.
Yeah, just take off on the runway.
So would it be something that would be uh, carrying a dischargeable payload, or would it be something that would be the payload? Because I mean, these things can be made cheap enough that you could literally, they'd be cheap enough you could fly one into a building or into a whatever it is you need to fly it into. I'm trying to think hard targets mostly because I mean it's not. You could probably use it against soft targets, but I mean I would think on something like that you'd be wanting to use it more on hard targets.
Right, hard target. Yeah, so you could build maybe hundreds or thousands of them at a relatively low cost, right?
Well, honestly, I didn't just go into the airframe. When I was thinking of it as a model airplane, I also
Right.
I
Yeah,
designed
like the large one. Yeah.
I designed a flying wing to go along with it so that that flying
Right.
wing can be one stamp and one press, and the thing is made. You'd have to
Uh
put
huh.
the servos in, and you'd have to attach the engine, but the fuselage would already be in the shape that it needs to be in.
Right. Now,
So I mean, it's
so
something that
you know how to do this. You know how to put servos on and that sort of thing.
I've been watching videos on that for a while. I've
Uh
never
huh.
made one that's radio controlled, but I have experience with radio control flight, and I also have experience. I have made airplane models and helicopter models. Some of them pretty realistic looking out of garbage. So
Okay. All right. That
I've
sounds
never
good.
made an RC
Yeah.
airplane though. That's the important part. But I've been watching videos on them. There's a channel called Flight Test, and they make a lot
Right.
of stuff out of uh, foam board that you get at the Dollar Tree,
Yeah.
and that's it's $1 a sheet. You know, I mean, it's cheap as shit. It's flimsy as crap, but when you double it over and start forming it into the shapes that you need and start getting
Right.
arches and roundels and stuff in it, what you're doing is you're adding to the structural stability of it and making it so that it's got a higher tensile strength.
Yeah.
So um like when I say carrying a payload versus being a payload, that's like if it's something that you're going to want to attach a few RPG rockets to and fly out and still have it come back, or would it be something where uh let's
Attach
say
like a machine gun to it, and then have it fly back as well, and the RPG as well, like you said, a straight charge, one way.
all right, well once you start getting into machine guns, that's a whole bunch of other complications on
Oh,
airframe that I
no,
can't
no, you
figure
don't have
out.
to worry about that.
That'll be
Yeah,
on
you don't
you.
have to. You don't have to worry about it. I'm just letting you know. That's all. Yeah,
All right.
that'll be. Yeah, that they'll do. You don't have to worry about that. I'm just letting you know. That's all.
So it would be more something for um rapid strike and getting the hell out of there more so than taking something that's cheap and just flying it into a target.
It'll be both.
It'll be both?
That's right. Yeah.
Alright, well,
I'd like to have both, yeah.
this engine would work excellent for both, the way that I designed it for a model airplane.
No, I'm saying, yeah, I'm saying you have to two different designs, I would imagine, yeah. As far as the pulse jet, right? Or would they be the same? You could use it on both.
You could use it on both. Matter of fact, if you were wanting to make an airframe that's 3 feet wide, you could easily run that with probably up to a 20-pound payload.
Wow, that's nice, yeah.
You could probably do that with one engine pretty easily. If you wanted to carry something...
That's good. 20-pound payload, huh? Okay.
Well, it's the power to weight ratio. The fact that it doesn't have a lot of moving parts, the fact that it doesn't have to have a lot of tight tolerances, it doesn't have to have all that bulky metal and mass, it doesn't have all that movement. It's just it's a simple design. As far as yeah.
Oh, by the way, now you said you would. What's the maximum would you put on one airplane? The max engine. You said a multi-lot, maybe 3 or 4, or what? At max? What would you suggest?
Well, when I was looking at the Horton 229, I was noticing that they have the area of it. It's about 36 inches, so basically as many as you can stack up into about that amount of area, because it's literally something that you could replace regular jet engines with and reduce the weight a lot. So basically, if I was to cluster them, I would cluster them into, like if you were to take a bunch of pencils, instead of having them all laid out on the table in a row, I would grab them all, squeeze them, and put a rubber band around them so they're all clustered together as a circle. And that way you can fit them into the same compartment.
Don't you have a problem, like, how do you get the water to all of them? You know what I'm saying? There's some in the mix center and everything. You already figured that out?
Well, that's the whole point of it, is that each one of them is its own individual engine. So basically all you have to do is figure out how to rig the fuel line so that you're feeding it to all of the engines. Quite similar to the rocket firing order that they set up for, like, the AH-1G Cobra in Vietnam. They had the rocket launchers on it, and it was a round pod with, I want to say it had 7 rockets, and each one of those rockets had a bunch of nails in them, called flechettes, and they would fire these rockets. They're anti-personnel, and when they get a few meters from the ground, they explode, and all of those nails go flying forward, and then they also have a die in it so that you can see where you hit.
Yeah, it's a radar. Radar hits the ground, they're like a certain amount of feet off the ground,
yeah. So the way that it's wired in so that you can fire the rockets, it would basically be doing the same thing with the fuel line on the front of the engine. You're not making an rocket, you're making a jet engine, and it is a jet engine. Matter of fact, it could be used, even though I designed it not to have any moving parts. If you wanted to, it would be very easy, the way that I designed it, to actually put a rod down the center, and have that rod be attached to a turbine at the back and the front, and that way it would actually control the air mass that's going through, and you can make the turbine on the front wider, basically turn it into a turbofan, and it's still just a pulse jet in the center. And hopefully, the way that I designed the Tesla Coanda baffles on the inside, it'll actually be able to do that at supersonic speed, which a regular jet engine like the Whittle or Von Ohain engines, they the way that they were made, you can't keep the fire going unless you bring the air down below the speed of sound. On a scramjet, the way that they do that is by basically squeezing the air. You're going so fast that it's going to build up pressure on the front end, and it's going to force the air in, and it's going to squeeze it because at the front it's just a little tiny point, and then as it goes further down the cone and then it gets further inside of the engine housing, it actually compresses it into this little tiny ring, and that kind of slows it down. But the thing is that if you can get it going like uh, basically like an afterburner, in an afterburner, you're going supersonic already. So it is able to combust at supersonic speeds. So the way that the combustor cans are made on a Whittle type engine, they drill a whole bunch of holes in the side of it. And they make it so that the supersonic air that's, even when it's, at a standstill, we're talking about stuff that goes from 18 to, I think the fastest engines I was reading about were 180,000 RPM. So, I mean, we're talking about a big range there, but 18,000 is about the lowest range of the engines that I've been studying. So, at 18,000 rotations per minute, that is going supersonic, but then it slows it down once it starts hitting those holes, and then about 70% of the air goes around the combustion chamber, basically to cool it and also to create pressure around it, while only 30% of the air actually goes into the combustion chamber for the ignition and the fire. Basically, what the holes are for is that the pressure that is around it, that 70%, that pressure that's around it goes through those holes and creates just enough of an air barrier between that flame and the wall of the combustion chamber that the combustion chamber won't melt.
Oh, wow. Oh, boy.
So
that's you're going about 400 or 500 miles an hour.
we're talking those would have gone faster.
Wow.
Yeah. I mean, we're talking about like, let's say the Horton 229, for example. It's got a Junkers Umo 004 engine. That engine is an axial compressor. Basically, it's got a bunch of fans on the front, and each one has a different pitch to compress it a little bit more. And that airframe went over 500 miles an hour. And I mean, that's not breaking the speed barrier or the sound barrier, but it's going pretty fast. And that was made out of just steel. The engine should have been made out of stainless steel, but by that point in the war, Germany had lost Turkey, so they didn't have any more chrome.
Oh, okay. Now, let me ask you something. How long will these stay in the air? The ones that you're building now. Yeah.
Well, that all depends on the weight and how much fuel capacity you're willing to put on there or sacrifice. I mean,
being say, how long would that say 2 pounds of water and 2 pounds of you're gonna run it on kerosene, right?
Yes, sir.
Okay, 2 pounds of water and 2 pounds of kerosene for one of your engines. How long would that last? Would you guess?
Well, that's quite a bit, actually. I'd say that would be. You might be able to keep it up for about an hour on something like that.
Wow, nice. So 1 pound of kerosene, 1 pound of water.
Well, it wouldn't be a 1-to-1 ratio like that. Not even close. The pulse jet in the center doesn't need to be very big. It produces so much heat that basically you use it small so that your expensive fuel doesn't hardly get used at all. And basically all you're trying to do with it is create a whole shit ton of heat to power the steam, because that's where you're going to get started. And then once you're already up to speed, I mean, the combination of the two really, honestly, I've never gotten it up to speed. Like, when you've got something that you make it that powerful and you don't expect it to be that powerful and it tears apart your stuff, it's not something that, you really get to test unless you have the facilities and the place to do it. As far as here, I can do the testing here in Washington State. I can also do it in California. I believe Oregon also has rocket clubs, and that's the important part for testing and showing is that you can join a rocket club for relatively cheap, and it's either a monthly thing or an annual thing. And the rocket club I was looking at here in Washington is $13 a month. It's easy.
That's nothing. Yeah. Yeah.
But that would give me a place where I could test it. I could make all the noise in the world that I wanted. It's out of town. I'm not breaking any noise ordinances. Things like that. Also, it would give me a place to film because I know that I've only been to one of those facilities before. It was mostly a bunch of Estes model rocketers, but there was some people there with bigger rockets, and it was basically they were putting on a show. But they had, the bunker portion is a cement building, and then off to the right of the cement building is a smaller building that's basically a metal frame with plexiglass around it, and that's where all the camera equipment and seismic equipment and all that stuff goes. And they actually can test all that stuff.
You're going to be protected when you, let's say, if you use your pulse jet, right? You're not going to be out in the open, right? You're going to be in a bunker?
Yeah, but I don't need to be. I mean, if I wanted to, I could literally make an RPG to basically fire a pulse jet like a bullet. I mean, you would only need, a couple of seconds to get it up to run-up speed, and then drop a shot of water in there, 1 to 2 ounces. You could even do it with an easy drop-in reservoir, and basically, dropping that water into the reservoir would fire that thing fast enough. It'd easily go through an SUV. I don't think it would necessarily go through something armored unless you put enough on there to get it up to, a really high rate of speed. But yep. Well, with that, you'd have to have a different nozzle on it, like the one that you were showing me. There's actually a nose cone similar to that you could literally fill that with a shape charge, and yeah, that basically the air would go around it. What you would have to do is make it kind of football shaped, like a little tiny Nerf football. I'm sure you've seen them.
Yeah.
And then around the outside, right at the very center of it, you make an aerofoil, a round aerofoil, that, has 2 to 4 spots where it's, anchored into the football type shape. The football type shape would have your shape charge in it, and then that ring that's around it is basically for the quanta effect. What it's going to do is that air that goes up and hits that little aerofoil is actually going to force that air to compress slightly and go along the tail end of it instead of dispersing, like I was saying with the 45-degree angle with the sound when you hit the speed of sound. It's kind of a similar effect, except you're not hitting the speed of sound. You're just basically performing within a funnel.
Yeah.
If that makes sense. Basically, what it would do is it would force, if you put fins on the back end of it, it would be forcing the air so that it goes past those fins instead of creating a lack of pressure there so that it has nothing to bite into.
Yeah, okay. All right, what else? Let me see. Okay, so you're going to be looking for a room?
I will probably start looking for that tonight. I gotta go I gotta go somewhere with internet. My phone doesn't really work well for internet. It updates like maybe once every 20 to 30 minutes. So, as far as looking stuff up, I can do that on my phone, but it eats a lot of minutes to do that. And, basically, since I'm on the road, I need that for like emergencies and stuff. So that's why I use the computer. Plus, the computer will hold a lot more information than my phone will. All my phone will do is take screenshots, and it's really full of screenshots right now. So it's something that, it's all stuff that's easy to look up. But if I'm going to be sitting there and, doing it for any amount of time, it's something I'm probably gonna go down to the local Starbucks, sit down, have a coffee, and take my time with it. That way I can,
Right.
you know, it sucks to jump on the first thing that pops up and go, all right, I found a room for $800 for a whole month, and you hop into it, and then you realize that there's one down the street for 150.
Yeah, $100 is right. Listen, make sure if you get the room they have Wi-Fi, right? That way you can use your computer there and everything.
Yes, sir. I will.
Yeah.
All right.
All right then. Well,
So I'm gonna write you up a materials list, and send that to you, basically to outline the different possible uses for it. The stainless steel versus um, the regular steel. I mean, if you're going to be using it for both long term and throwaway, you'd literally be making the same engine. Just one of them would be made out of stainless steel that'll last long, and the other one will be made out of something that's basically mass that'll help to assist. I mean, it's only going to be used once. There's no reason to spend an ungodly amount of money for it.
Right. Yeah.
All right.
Okay.
I think I had one more question I was going to ask, but
Sure. Good.
shit, I can't remember. I might already asked it.
Well, you can email me the question.
Yes, sir. Well, basically, I just like for me, I do get into weapons. I like a lot of them for their mechanical properties and how they work. I actually made something called Swords to Plowshares to turn military technology into civilian technology. And I found out that military technology is so specific to the military that really it's 99% of it is unnecessary junk for the civilian world, so you're better off just starting over.
Oh, yeah. By the way, you like to do mock-ups?
I do.
Yeah. All right. I'm just asking. All right.
Oh, I remember now. As far as making these, is there any possibility that whoever it is that this goes to would use it for like civilian transportation and things like that, or would this be a pretty much a military exclusive thing?
Civilian transportation? I don't understand. How would you use it for civilian?
All right. Well, there's a way that you can make baffles that basically like a forced air intake. You'd have to look up the Chrysler car, but it's a thermal exchange. The incoming air, basically the grill of your vehicle, has a big opening, or the possibility of having a big opening. Now, the air goes in there, and as long as it goes through, basically, you've got a piece of metal that's in between the incoming air and the outgoing exhaust. So the outgoing exhaust is cooled down by the incoming air through the metal heat transfer, and the incoming air is heated up, which allows it to combust easier, and also you get more thrust out of it. So basically, what you would be doing is taking one or two of these things, and you would be putting one of those baffles around it. The thermal transfer would basically make it so that you can have an area that you can cover with rubber or even a lighter weight foam or something like that, so that people don't have to actually hear the pulse jet anymore. And it also makes it so.
Put it on like a car? Or
yes,
something?
sir. Yes, sir.
Huh?
Yes, sir. Absolutely.
Oh. Yeah. Oh, I see what you mean. Yeah, yeah. Okay. Well, what good would that do over, let's say, regular gas engine? What advantages would you have?
The advantages are it's not a 1-to-1 ratio on fuel. It's about 1 gallon of kerosene for probably every 10 to 15 gallons of water. I mean,
Wow.
it's something that
Really?
basically
How long would that last? 1 gallon of water with 10 gallon? 1 gallon kerosene with 10 gallons of water. About how long would that last?
Oh, God. I don't know. I would have to literally have the airframe and do the testing and find out what the specific numbers are to do that math. And
Alright.
that would require basically getting started and doing some testing and getting some numbers.
Yeah. So you're talking maybe a couple hours at least?
Oh, God, no. It'll take... That would probably be at least a couple hours of testing, yeah, I suppose. Just the testing
how long
part.
would it last? Like would you guess? 1 gallon of kerosene, 10 gallons of water.
Well, water is pretty friggin' heavy, so I would say it would last...
Yeah. 7 pounds a gallon, yeah.
On just one of these pulse jets, you might get it to go 10 or 15 hours, actually.
Jesus God, are you kidding me? Oh my God.
Well, all right. If you imagine that you one of those little milk containers you used to get in grade school, right? One of those milk containers, if you fill that with gasoline and you put it in the pull-on weed eaters, those things will go for about an hour, and that's just 1 quart. I mean, we're talking about a gallon is a lot more than that. I mean, a gallon is a lot more than that. And we're also talking about the fact that now we're not powering something like that that's entirely dependent upon that fuel, because it's also got water. So that water is doing a lot of that work, so you're using less of the other fuel. But there's also the minimum allowable amount of fuel that you can get to combust. I mean, if you got 1 or 2 little tiny microscopic droplets, in every one of them, it's not going to do shit. It's not going to combust. It's not going to do anything. So it has to be, enough of a flow to keep it going. But it's, it's something where I don't even know how to explain that part right now. But like I said, there's a lot of concepts that go into it, and a lot of study and education. Like, this is an idea I had years ago, and I've basically been working on it and adapting it in my head ever since. But probably about 99% of the work that I've done is in my head. And then when I got something figured out, I put it together, I test it, I see if it works. Most of my concepts work. I've only had a couple of them that didn't. And the reason that they didn't work is because I didn't have the materials or the tools to do it right. So, I mean, I do consider them...
Do you need more tools and material?
Well, right now, being as I'm in a vehicle and I haven't found a place to build yet, I'm gonna focus on that first rather than add more weight. If something happens to the vehicle, I don't want to lose everything and have even more of a loss. What I want to do is I want to try to focus on getting something accomplished first, and then, basically at this point it's just a matter of having a place to build it. Are you there?
Oh, yeah.
I think somebody was bleeping at my phone.
Oh, okay.
So yeah, I mean, for me, I'm not really a warmonger. I'm into peace. So when I think about making this stuff,
yeah, so am I. Absolutely, I don't like war either. Yeah, no, I'm not a warmonger. Trust me. Even though I'm going to use this for a military purpose, I'm not a warmonger. Not by any means.
All right.
I don't like those. Yeah, I don't like those wars in the Middle East going on and everything.
Me neither. But for me, I was just wondering if this is a country that might possibly, if you put the idea in their head, would they possibly at least try it out on something, civilian like that? Because I would be willing to provide blueprints and everything like that free of charge, my own personal time, to see something like that happen.
Yeah. All right. But so you wanted to use it as a civilian? I didn't understand what.
Well, if it's something that they want to use just exclusively for the military, I don't know. That kind of it. Yeah, I'm here. That engine, the 50 pounds of thrust one. If you were to fit out a Volkswagen Beetle, take the engine out of a Volkswagen Beetle and replace it with just one of these, you could power a Volkswagen Beetle no problem.
Wow, amazing! Well, that little lightweight engine, huh?
Yes, sir.
Oh, that's interesting. A Volkswagen engine weighs what, 70, 80 pounds?
They're more than that. The
That's amazing. That little 50-pound thrust. What's it weigh? About 15 pounds or 10 pounds? Wow.
3 pounds.
Oh my gosh. Plus the fuel, yeah. Boy, that is amazing, yeah.
Yeah, I was only able to bring the weight down like that because of simplification. Where a lot of other people went, all right, well, I need to figure out how to make this piece right here and that piece right next to it. So there's so little room in between them that no air passes through or escapes. And I went, well, why don't you just take that outside part that you don't want to touch, and why don't you just attach those two pieces together and make them both spin at the same time?
Yeah.
That actually allows you to take away nearly all of the internal components, and basically you just put it on a spindle. It's attached at the front and the back, and it spins on the spindle.
Yeah, but the thing is, how do you put a throttle on it?
Well, same way as
you. Put it on a Volkswagen, you'd have to make a makeshift throttle, obviously.
Well, when I was looking at it, basically as far as the model goes, you notice that I put down mouse traps on that list, right?
Yeah.
Yeah, you attach a 9-gram servo to the mouse trap. The mouse trap holds your fuel lines closed. Since one of them's water and one of them is gasoline or kerosene, and literally, if you ran out of kerosene, you could literally fill it up with gas. The very same machine on the very same day without changing gas tanks, without changing fuel lines, you could do that. But the mousetrap with a 9-gram servo on it, one of the tubes is wider and one of them is thinner, and the thinner one is for the kerosene and the wider one is for the water, because you're going to be using more water. It's converted into steam. But the mousetrap is wide enough that the strap, the part that breaks the mouse's back or neck or whatever, that part right there is strong enough to actually hold those fuel lines so they're closed.
Okay.
So a 9-gram server gives it just enough power that with the resistance of the fuel lines wanting to go back to their original shape, and the 9 grams of pull that the servo has, you can actually control the amount of fuel flow by the same way that you would move the tail of the airplane. I mean, you're basically just doing that with the mousetrap instead of a wing.
I see. Oh, wait a minute. I'm not sure. I see about the fuel, but how do you use a mousetrap? Do you use the elevators and the rudders?
Well, what I was referring to is...
All you need is a servo, right?
Right. I was referring to the servo usage. Like when you're talking about the flaps and the ailerons and all of those parts, the servo, has a rod and it pushes back and forth, and, basically, either left or right if it's on a control surface, or up or down if it's on a wing surface.
Aileron.
Or, in the case of the fuel line, it would be controlling, whether or not the fuel line was open or closed is all. It's pinching it or it's not pinching it.
It's not partially open or anything. It's just completely open or...
Well, that's the thing about the servos. The servos allow you to control that. I mean, when you have a throw on it, which is what it's called when it moves the whole control surface, it's called a throw. That's the amount that it moves when you move the control stick. You can move the flaps just a little bit. You can move them a lot. You can move them kind of in between. It's not like a light switch where it's either on or off.
Right, of course.
So you can adjust the amount of fuel that you have going in and out of there just by using a servo and a mousetrap.
Right. Oh, okay. Mousetrap. Oh, it's simplified. That's okay. I like that.
Yes, sir. Well, most of the stuff I designed...
You know, the kids thing. Keep it simple, stupid, you know?
Yes, sir.
Yeah.
Absolutely.
All right, Sean, let me know when you find a place, room. And also keep an eye out. You know, make sure it should have Wi-Fi. You know, this way you can stay in contact with me a lot. And maybe if you're lucky, there's a garage nearby I could rent, and you can work in there. Who knows? Well, we'll see. Yeah.
Yes, sir. Well, I'll look around and see what I can come up with.
All right.
I'll probably get a hold of you. Is tomorrow morning too late?
For what? Call me?
Yeah, because I'll probably be at it most of the day.
I get up around 6 in the morning.
All right.
Call me you call me anytime. Yeah.
Yes, sir. Well, I'll call you as soon as I get up then. I'm gonna go ahead and head to Starbucks now so I can start doing some research, and I'll call you in the morning. Sound good?
All right. That sounds good, Sean. Thanks very much.
Yep. Thanks, Andre. Be safe.
All right. Have a good night. Bye-bye.
Bye.